Hi everyone, in this video we look at a couple of examples of vertical and horizontal translations of functions. So in problem 1 we're asked, how is the graph of y is equal to f of x minus 3 plus 1 related to the graph of f of x? So recall that if you subtract 3 inside the function of f of x, this is a horizontal translation to the right 3 units. So, and this one constant that we're adding outside of the function is a vertical translation 1 unit upward. So together we've got this is a horizontal translation 3 units to the right, and a vertical translation it's a vertical translation 1 unit upward, so 1 unit upward. So we shift 3 units to the right, and we shift 1 unit upward. Next, let's look at problem 2. It wants us to graph y is equal to the absolute value of x plus 3 minus 2. So to do this, let's look at the parent function. So the parent function here is let's call it let's say the parent function is y is equal to the absolute value of x. That's the function that we're transforming. So if we take y is equal to the absolute value of x, let's look at what transformations have been done in the equation. Y is equal to absolute value of x plus 3 minus 2. So this is a horizontal translation 3 units to the left, and a vertical translation 2 units downward. So those are the different transformations that we've got here. So let's graph y is equal to the absolute value of x. Remember that the y is equal to the absolute value of x looks like this. It looks something like this. It's y is equal to x when x is equal to or greater than 0, and it's y is equal to negative x when y is less than or when it's less than 0. So this is the graph of y is equal to the absolute value of x. Now let's translate this graph 2 units downward, 3 units to the left. So let's look at all the points on the graph. Okay, so this point we have to translate it 2 units downward and 3 units to the left. So this point gets translated to this point right here. So we have 0, 0 is now negative 3, negative 2. Okay, and now we can just kind of follow now that I know where this point is, I can just follow this pattern where I go over 1 up 1, over 1 up 1, because the points, it's still going to follow this line's still going to follow the same slope because I've only shifted each of these points. I haven't actually like stretched them or the shape. When you translate a function, its shape is still the same. It's still congruent. So I should have another point here, a point here, a point here, a point here, a point here, and so on and so forth. And a point there. Okay. And I should have a point here, a point here, a point here, a point here, and a point here. So this green graph is the graph of y is equal to the absolute value of x plus 3 minus 2. And it kind of looks a little bit odd when I graph it with this whole branch graph. So I'm just going to graph it so that I just graph to the same y values. So maybe it should looks a little bit the graph looks a little bit better if you graph it like this, and then you just include arrows at the end of the function. You don't extend it right to the edge of the frame. It looks a little bit goofy and non-symmetrical if you graph it right to the edge of the frame. So I'll just include arrows, and the arrows denote that this graph continues on. So this is the graph of y is equal to the absolute value of x plus 3 minus 2.